Hello, I'm José Pina-Sánchez, Professor of Quantitative Criminology at the University of Leeds and Co-Director of Social Research Methods at Leeds. In this short video, I'm going to introduce very briefly what we mean by methods for the adjustment of measurement error. More than a specific method, what I will cover is the rationale behind a wide range of methods that can be used to enhance the robustness of analysis that rely on data that is prone to measurement error. Here's the problem. Much of the data that we use in our research is far from perfect. One way in which that can be the case is when the data collection process is, for some reason, flawed, which results in recorded values in our datasets that do not reflect exactly the true characteristics of the subjects or cases that we seek to study. Survey data is the clearest example, since this type of data is affected by all sorts of problems, such as social desirability bias, interview effects, or recall errors. So the data that we obtain is not always valid and reliable. However, measurement error is not solely confined to survey data. Often, administrative data is just as problematic. For example, we commonly rely on police statistics to measure criminal activity in small spatial areas like streets or neighborhoods, where no other data is available. However, because not everyone who is a victim of crime reports this to the police statistics are strongly biased. So what are the implications of this problem? Well, in simple cases, when our research is limited to the analysis of descriptive statistics, we can anticipate the impact that measurement error will have in our findings relatively well. For example, we can anticipate that the bias in police statistics will lead to underestimates of the true extent of crime. This is what is known as the dark figure of crime. We can also consider retrospective questions when we ask about events that took place in the past. These are normally affected by recall errors, which we can think of as a form of random errors. In those instances, the variability of our observations will be artificially increased, making them less reliable. However, besides affecting the measurement error properties of the variable prone to error, we might encounter a more complex problem, which is harder to anticipate. When we use these flawed data in causal models, that is, when we want to explore the effect of one variable on another, and one of them is affected by measurement error, it is likely that the estimated effect is biased. It is often quite hard to figure out the direction and magnitude of that bias, and to make things worse, this could happen even when the measurement error process is completely random. In those instances, when the only data available is prone to measurement error, we normally do one of two things. We either decide to abandon the project, accept that research cannot be done, or we carry it out anyway and hope for the best, perhaps include a couple of caveats and hope that reviewers will not raise too many objections. Either option is suboptimal. If we use this data and do nothing about it, we might be polluting the evidence base. But if we give up entirely, we are unduly limiting our understanding of the topic, which can be particularly problematic when no evidence at all is available, or when the consensus about the question at hand is wrong. We can consider a third option: use the data, but also apply adjustments to the measurement error problem. So there is a growing range of methods that could be used to adjust for the potential biasing effect of measurement error. Roughly speaking, we can distinguish methods that rely on finding additional observations of the cases of interest to sort of calibrate the variable that is prone to measurement error. Some examples are multiple imputation, latent variable estimation, or regression calibration. Then we can also consider methods that seek to model the measurement error mechanisms as we simultaneously estimate the causal effect of interest. Some examples are Bayesian adjustments, Markov simulations, or CMEX. Let's take a quick look into one of these methods from the latter group. In a recent project funded by the Economic and Social Research Council, I was part of a team that developed an R package, so researchers using police-recorded crime data for the estimation of regression models could explore the robustness of their findings easily. This method works as a form of sensitivity analysis. So, after a naive model using police data is estimated, we facilitate the simulation of adjusted crime rates according to the types of measurement error mechanisms that we suspect to be present. Then we re-estimate the model using the adjusted data to assess the robustness of our results. In this example, the black dot is the naive estimate of the effect of strong community bonds, what we call collective efficacy, on criminal damage in Greater London. And the black lines represent the expected effect under different types of measurement error mechanisms. For example, each of the panels shown here report different recording rates, 25, 35, and 45%. We can see that the more underreporting of crime, the wider the distance between the naive and the adjusted estimates. so the larger the bias due to measurement error. However, we can also notice that in the three scenarios, we see a downward bias, which means that our naive estimate is unduly conservative, and the crime reduction effect of collective efficacy is likely stronger than we think. In conclusion, measurement error is a much bigger problem than we like to acknowledge. It is very widespread, and it can bias our findings massively in ways that are difficult to anticipate. But that doesn't mean there is nothing we can do, and we should just give up using data that is not perfectly measured. If instead we think carefully about the specific types of measurement error problems present in the data and use appropriate adjustment methods, we can minimize this problem, or at least assess the robustness of our conclusions so we can make the most of our data. Now, if you want to know more about this topic, these two are excellent textbooks, Carroll's and Gustafson's. I strongly recommend you to take a look at them. If you want to know more about measurement error in police data, you can visit our website, recountingcrime.wordpress.com. And if you want to know more, or if you want to explore more hands-on materials to practice different measurement error adjustments using R, you can take a look at the materials from my short course on measurement error, available in my GitHub account that you can read over here. Thank you.